We're now given a circuit that has dependent and independent sources, and we're being asked to find the Thevenin equivalent. And again, the Thevenin equivalent is simply a voltage source in series with the resistance and with the resistor, and that resistor is R Thevenin and V Thevenin. Now our task is to find it. All right, so we start by finding V Thevenin. Well, V Thevenin is simply the open circuit voltage, and that will be this voltage here plus minus, and that's a V open circuit, which happened to be also the V naught that we have in the circuit. So all I have to do is just figure out that, and the way we compute it, well, this circuit here doesn't, like, this part of the circuit and this part of the circuit are separate. They don't, like, if a current goes in here, there's no way it can come back, so the current in this particular branch is 0. Okay, so that means everything we need to do for this particular circuit is on this part. So the V output, or V open circuit, is simply V naught, and that is well, it's the current times 25. Well, I times R. Well, what's the value of the current? Well, the current that is going to it is actually just simply 20I from this current source, but it's going to the negative side first. So passive sign convention tells me you have to put negative in here, and that will be 20I, that's the current, times the voltage, or times the resistance, which is 25. So that will be in amps. Okay, so that's that. But wait a minute, what about I? Well, I happen to be here, so we need to compute what that value of I is. Well, the value of this I in here, we're going to write it. It's simply, I is simply the voltage difference between that 2 kilo ohms, and that voltage difference is just 5 minus 3V open circuit, because the voltage here, let me just write it, this one here is 5 volts. Okay, and this one here, let me just do this here. This one here is 5 volts, and this one here is just simply 3V naught if I put my reference in here. All right, divided by 2 kilo ohms, but because we have this part is in ohms and this part is in kilo ohms, we need to adopt some sort of a convention. So I'm going to convert every kilo ohms to ohms. So just so that we don't get confused, I'm going to tell you that this is simply 2000 ohms. Okay, so that we divide by 2000 so that the units are all correct. Okay, so now what we have to do is we have two equations in here. All I have to do is just take the I and just substitute it with its value in here. So we do that. So I'm going to take this here, substitute it. So it tells me V open circuit is simply negative 20I. Well, it's not I anymore because we are substituting it. It's going to be divided by 2000. 5 minus 3V open circuit times 25. And that will give me, well, this is one equation, one unknown. That will give me a V open circuit of negative 5 volts. And that's basically my V Thevenin. So V Thevenin happened to be negative 5 volts. All right, so that's we found the first one. So now our next task is to find what the R Thevenin is. So we have 3 methods. So method 1 tells me turn off all the sources. Unfortunately, I can't turn off dependent sources, so method 1 does not apply. So I cannot use method 1, okay? So that tells me I need to go and use method 2. Okay, and what does method 2 tell me? Well, method 2 tells me, okay, so instead of having open circuit, what we need to do is we need to short circuit it. So let me just clean things up in here. All right, so that's what we have. And now I don't have an open circuit. What I will do is I'll say, well, I'll have a short circuit in here, and I'll be interested in figuring out the I short circuit here. Okay, so how do we compute I short circuit? Well, of course, if we compute a wire, like if we put a wire across a resistor, that resistor is basically shorted out. So this resistor doesn't exist here. And the voltage across it anyway is 0 because it's across a wire. Okay, so what would be the value of I short circuit? Well, simply the value of I short circuit is negative 20 times I, because this I in here, this voltage, this current source in here is flowing. It's just going to go in the opposite direction. That's why we put negative. So that tells me, well, you need to find what I is. Well, I is here. So I is simply, well, we found it a few seconds ago. It's the same, nothing changed, okay? And that is basically 5 minus 3V open circuit. Well, it's not going to be open circuit, it's V naught this time. And V naught is not the same as V open circuit over 2000. Actually, what's the value of V naught? Well, here's the value of, this is V naught. V naught is the value across, the voltage across the wire, so it's a 0. So all I have to do is just remove these here, and that's basically the value of the I. So what we need to do now is we combine them. So I short circuit will be negative 20 times 5 divided by 2000, and that value would be negative 50 milliamp. Okay, You can compute it, you're going to get the number in amps, but then I converted it. So that will be negative 50 times 10 to the negative 3 amp if you wanted to. All right, so we have everything to compute the R Thevenin. Well, we know the R Thevenin is just simply V open circuit divided by I short circuit. And by the way, if I have asked you to compute the Norton, that will be your I Norton. I Norton would be negative 50 milliamp. Okay, but now we're computing R Thevenin. Well, what was the value here? It was negative 5, negative 50 milliamp, because this is a milliamp, so the result will be in kiloamps, in kilo ohms. So 5 divided by 50, and that will be just simply, I think it's 100 ohms. Okay, you will get 100 times 10 to the negative 3 kilo ohms, and it's like, and then you just multiply by 1,000, and you'll get 100 ohms. So that's basically the R Thevenin. All right, so that's basically method 2. Can I apply method 3 with connecting the voltage, a test source? Yes, I can. So let me just do that. And now let's use method 3 to find the R Thevenin. And method 3 tells me, well, we're going to turn off or deactivate all the independent sources. That means I will have to remove the voltage source in here and replace it with a simple wire. Okay. And I don't have any other independent sources. Everything else is dependent. We keep it as is. And then what we do is we connect a test source from the outside in here, and it can be a current source or a voltage source. I'll just use a voltage source in here. I'm going to call that VT, and you can specify that this is 1 volts, for example. And our task is to figure out what the IT here is. And once we know, we just divide them by each other and we get what R Thevenin is. And of course, VT will happen to be the same as V naught, by the way, because they're in parallel. So I'm just going to put here as 1 volts because we will use it later. All right, so now what are we looking for? We're looking for the value of IT. So I'll write KCL equation at this particular point. I know that the current going in here is just simply 20I. I know the current, well, I don't know the current in here, but I can compute it. I know the voltage across a resistor. So that simply is 1 divided by 25. So let me just write this here. It will be I25. Okay, so let me write the KCL equation. The KCL equation at that particular point will be the 20I. It's just simply, it gets added. It gets added here. Okay. Because both the I25 and the I20 are leaving, they get added to the I25, and that will be the I test that I'm looking for. Okay, but I know what I25. Okay, well, 20I plus I25 is just simply the voltage, which is 1 divided by 25, and that equals I of t. Well, what about I? Well, I is this particular current, and this current is actually also the current across a resistor that I know the voltage. I know the voltage across this resistor. It's actually this voltage because it's based on the voltage source. So we know that I is simply negative 3 V naught divided by 2000 ohms. Okay, but what about V naught? Well, V naught, we know it's 1 because we started by saying V naught is 1 because it's in parallel with the test source. So that will be negative 3 divided by 2000. Okay, so I can combine these, and that tells me the I of t is simply 20 times negative 3 divided by 2000. That's the value of I, plus 1 divided by 25, and that will be 1 over 100. All right, and that's of course in amps because we're dealing with voltages and ohms. All right, so that means the R Thevenin is simply V of test divided by I of test, and I know that the V of test is 1, the I of test is 1 divided by 100, and that's in volt. The other one is in amp. That means the result that we would get is 100 ohms. And that's basically the R Thevenin value that we found before. So the values we found are the following. We found that this here is a voltage source, and this is here the R Thevenin. So R Thevenin will happen to be 100 ohms. And of course, V Thevenin will be, we forgot what it will be. V Thevenin is negative 5 volts in here. Okay, so that will be negative 5 volts, and we replace that particular circuit with its Thevenin equivalent.